Okay, we're hopefully getting good at this now. We're going to do a distance one, or a dist function, which returns the distance between 2 points. So again, very similar. It's a calculation, right? Input and an output, Fahrenheit to Celsius, Heron's formula should be similar. This dist one is going to come in handy, especially if you like games. When we get into games and stuff, collision detection, you want to know the distance between two things on your canvas. But anyway, let's look at this distance one. So given 2 points, x1, y1, and x2, y2, the way we find the distance between those 2 points is just Pythagoras' theorem, right? Find this horizontal distance, the run, right? So x2 minus x1 is the run. Find the rise, y2 minus y1, that's the rise, and then run squared plus rise squared equals d squared, right? Then we square root the result to get d by itself. So this is simply Pythagorean theorem, and we find the distance between these 2 points. So the name of the function is dist. I'll copy that. The data in are the x and y coordinates of the 2 points, and it returns the distance between the 2 points. So this makes this 0, 0, and 3, 4, makes a nice 3, 4 triangle, and the hypotenuse is 5. So the distance is 5. All right, so again, I recommend try to do this on your own. Pause the video, right? Define it on your own, and then unpause to see me do it. All right, here I go. So function dist, like so. And then we want an x1, y1, x2, y2. Make sure you don't get the order of these mixed up, because that'll really make things go bad. And what do I want to do here? I'm going to return. I think, well, we could break up. This calculation is a little bit more complex. So we could do something like this. Let rise be assigned y2 minus y1. Let run be assigned x2 minus x1. And then I'm going to return the square root of rise squared plus run squared. Right? That star star is to the power of 2. So rise squared plus run squared. Let me just double check. Rise squared plus run squared, and then the square root of that. Or run squared plus rise squared, doesn't matter. Yeah, that should work. Now, we don't have to do this. We could replace the rise with y2 minus y1, and we could replace the run with x2 minus x1. And this is a little bit just, they should both work. This is just a matter of preference. But you know what, like, yeah, it's preference. The other one's a little easier to read, but you know what, we're defining this beautiful dist function that's easy to read. So what's inside of this could be a little complex. It's kind of encapsulation, right? We're hiding this complexity inside of the function. But anyway, that's the function. Okay, it takes in those 4 arguments, uses those point coordinates to calculate the distance. Okay, take care, and we'll see you in the next video.